for Unit 8, we have quadratic equations, and what we're going to do is start out just by simplifying square roots. So we so far know about perfect squares, right? Can somebody give me an example of a perfect square, Abby?
4.
4 is a perfect square because the square root of 4 is equal to 2. What is another one, Justin? 16 is a perfect square because the square root of 16 is equal to? Good, 4. What about, hold on, not a perfect square. How about 80? Is 80 a perfect square?
No.
Can I take the square root of 80? We can now. We are going to learn today how to simplify this as much as possible. Okay? Don't worry. Don't worry. Okay, so first thing we have to realize is that we have a new property called the multiplication property of square roots. Okay, so first thing we have to realize is there's a multiplication property of square roots, which means if I have a square root of something, right now a and b, we're just talking general terms here, I can actually split that up to the square root of a times the square root of b. So, for example, if I have the square root of 54, what two things can multiply to 54?
6 and 9.
6 and 9. So this is the same as the square root of 6 times 9, right? Which is the same as the square root of 6 times the square root of 9. Okay, so I can just split it up. Does that make sense? Okay, now, Abby.
Is that for the
Hold on. What? Yeah, what's the square root of 9? 3. So this is the same as 3 times the square root of 6, and we just simplified it as much as possible. We can't take the square root of 6, so we just leave it. Okay? We will practice with this part. This is what you need to realize right now, this part right here.
I love how
That's okay, right?
just right there.
Okay, we will fix this. We will do this part right now. Okay? So let's write down the steps first. Okay, step 1. We want to rewrite the radical using as many perfect squares as possible. So notice how we were able to rewrite 54 using a 9, and 9 is a perfect square? Okay, so we want to first rewrite the radical using perfect squares, as many of them as we can. All right. Okay, after we rewrite using perfect squares, we are going to simplify the perfect squares, which means that we take the square root of those perfect squares. Okay? The last step is that we are going to write the answer as a radical. That's what they are called.
Thing we're gonna ever do.
Okay? So this is called a radical. So you're going to rewrite your answer as a radical. So, let's look at example 1. For example 1, I have 6 square root of 36. If I have the 6 outside of the square root, that means it's being multiplied. Okay? So it means that this is the same as 6 times square root of 36. Okay? Everybody okay with that?
So all you're doing is times.
Good. What's the square root of 36? 6. So let's rewrite this as 6 times 6. So what's my answer? 36.
So confusing. Like it's not. It's like it's easy, but it's.
Change this. Let's not have this write the answer as a radical. Let's have it write the answer as a product. That's a little bit better. Write your answer as a product, which means that we multiply everything that is in your answer, right? Okay, that's a little bit easier to understand. So we're not writing it as a radical, we're writing it as a product. Sometimes it will be a radical, sometimes it will not. So what I was explaining just a second ago is if this number outside the radical was a 5, it would have ended up being 5 times 6, so your answer would be 30. Is that better? So let's write that one too. Let's do 5 square root of 36. That's it. Would be equal to 5 times square root of 36 is 6, and 5 times 6 is 30. Make more sense? Okay. Example number 2. Square root of 8. Can I take the square root of 8? No. Can I rewrite 8 using a perfect square?
Yes.
Yes. What would it be?
4.
4 times 2. So let's first rewrite this as the square root of 4 times 2 inside the square root. Okay. And then let's use the multiplication property. So that's the same as square root of 4 times square root of 2, right? We just split it up. Okay, now I can take the square root of 4. What's the square root of 4? 2. Can I take the square root of 2? No, so we just leave it as square root 2. And that's your answer. That's as simplified as you can go. You have to keep the square root outside the 2 because we can't take the square root of 2. So we simplified it as much as we possibly could, so we leave it as square root of 2. Example 3, I have 2 square root of 75. So this is the same as 2 times the square root of 75, right? It's like this is being multiplied. Okay? So, can I take the square root of 75? No, but can I split it up using a perfect square? 25 times 3. So this is 2 times the square root of 25 times 3, right?
You can take the square root out of 25.
Good. This is 2 times the square root of 25 times the square root of 3. What's the square root of 25? 5. So this is 2 times 5, right? Can I take the square root of 3? No. So times square root of 3. And then we can actually simplify this one step further, right? 10 times the square root of 3. Or we just read that as 10 root 3. And that's your answer. You don't have to put the multiplication. I'm only writing the multiplication so that you understand that whatever's on the outside is really being multiplied by that square root. Once we get it, we don't have to write it anymore.
Does it seem like this?
I have 100 minus 64. Now, I want you guys to understand a square root is in order of operations under the parentheses category. So whatever's inside the square root we have to do before we actually can take the square root. Okay, so we have to do the 100 minus 64 first. So what's 100 minus 64? 36. So this is the same as the square root of 36. And the square root of 36 is 6. And that's your answer. So we have to subtract first. Okay, what about square root of 81 over square root of 20? What do you guys remember about square roots with a fraction in them? We can rewrite this, right? Square root of 81 over square root of 25. You can actually rewrite this and put smaller square roots on the top and the bottom. They are the same. You would get the exact same answer. Okay, so this is equal to, what's the square root of 81? 9. Over, what's the square root of 25? 5. Can't I simplify that anymore? No. So that's your answer.
Oh, that's easy.
So if you ever see a fraction inside the square root, split it up and take the square root of each one. Okay? Okay with that one? Okay, last one. Last one is just a whole bunch of plugging in. There's a couple examples like this on your homework, and this is actually building on something else. Okay, so I want you to evaluate the square root of b squared minus 4ac for a equals 4, b equals 5, and c equals 1. So all we're going to do first is plug it in. So this is the square root. Make a nice long square root. B squared, what's b? 5. So of 5 squared minus 4 times 4 times 1. Okay? So all I did was plug everything in. Okay? Equals square root. What's 5 squared? 25. Minus 4 times 4 is 16 times 1, 16. Yeah, minus 16, right?
Can't you
Equals?
square 25?
Yeah, but
Not yet, because it's subtraction. It's not being multiplied. So we have to do the subtraction first.
So it's 3.
So what's 25 minus 16?
9.
9. And what's the square root of 9?
3.
3.
Oh.
If it did not come out to be a perfect square, my answer would have looked something like 10 square root of 3. Okay?
Are we stopping at that?